Hello, welcome back. Week 2 of quarter 4. We are looking at electricity, mainly how much it costs us to run different appliances. So from last week, these are the 3 equations that we worked our way through. Delta V equals I times R. The voltage is equal to the current times the resistance. And then we have 2 power equations. One works specifically for electrical power. P equals I delta V. The power is equal to the current times the voltage. And then the other power equation is one that we worked with before, and it works for any type of power. Like when we were measuring the horsepower of a car, or the power of us lifting a weight, or pushing or pulling something, and that is power is equal to work over time. Okay, all of these equations, when you use them, we use the units that are in the metric system, which for power is going to be watts. So if you use these 2 equations with our regular, our amps, our volts, our joules, our seconds, they always come out in watts. Okay, this week, we just have to switch this slightly, and that is because we're dealing with money. So the only time you have to work with different units of power is when you're dealing with money or the cost of electricity. Okay, to find out how much something costs to run using electricity, the electric company uses kilowatts. You would need too many watts, it would take up too much space, and when you look at the dial, it only has 5 or 6 dials on it. Watts would need way more than that. So they keep it in kilowatts, and they charge for it in a kilowatt hour. All right, so electric companies charge for electricity using the work done by your house each month. So the electrical work your house does each month, they keep track of that, and each month they charge you for it. Okay, how they measure it is in a kilowatt hour, which is kWh. We learned that unit last week. We learned how to convert between it and a joule. Now we're going to be using it as we solve for the cost of something. For Dakota Electric customers, this is an old data point, so it may have gone up slightly, but 1 kilowatt hour, every kilowatt hour that you use, it costs you in dollars 0.101, which if you moved it to change it into cents, would be 2 spots over. Every kilowatt hour is about 10.1 cents. Okay? Generally, people use anywhere from about 750 to 2,000 kilowatt hours each month. You get charged according to how much electricity that you use. Okay, so here are the steps. This is work in through, only works for finding the cost of electricity. Okay, step number 1, we have to have our power in kilowatts because we need our work in a kilowatt hour. We have to make sure our time is in hours. We will use our power equals work over time equation to solve for the work, and it'll come out, because this is in kilowatts and this is in hours, they multiply over, it will come out in a kilowatt hour. And then once you know how many kilowatt hours that you use, then you multiply it by the 0.101 to change it into money. Okay, so those are the 4 steps. We're going to do 2 examples together, and then we're going to do one of the problems together on the back side as well. Okay, you use a 1,250 watt toaster for 10 minutes a day. Calculate how much it would cost. Okay, so I need to know the power and the time. I'm going to solve for work using this equation right here, and then change it into money. Okay, power, 1,250 watts. I can't leave it in watts, I have to convert it into kilowatts. A quick reminder, if you don't know how many watts, it's 1,000, are in a kilowatt, it is on your equation sheet. Okay, so to change from watts to kilowatts, you just divide by 1,000, which would be 1.25 kilowatts. For the time, I have 10 minutes. I have to have my time in hours. I need to be in a kilowatt hour. Time has to be in hours. That is step number 2. There are 60 minutes in an hour. So I got to set it up. 60 minutes go on the bottom so I can cancel that out in 1 hour. If I take 10 and I divide it by 60, I get 0.167 once I round. 0.167 hours. Okay, I now have step 1 and 2 ready to go. I am in a kilowatt, I am in an hour. My unknown is work. I am going to use the power equals work over time equation to solve for work in a kilowatt hour. Okay, so switch into a different color. My power, 1.25 kilowatts, equals the work, that's what I'm solving for, over 0.167 hours. Okay, this is on the bottom. I have to multiply it to the other side. When I do that, I find that my work is, I'm gonna keep a bunch of decimals and then round later, 0.2083, and I am in a kilowatt hour, okay? Because I took that times that, I'm in kilowatt hours. The last step that I have to do in order to change it to money is multiply it by how much it costs. So in 1 kilowatt hour, they charge us $0.101, the 10.1 cents. So if I multiply this number, the kilowatt hours, by the price per kilowatt hour, I end up with it being approximately $0.02, which would be 2 cents. All right, so your toaster costs you about 2 cents to run it a day. What about something a little bit bigger? Okay, the New Year's Eve ball in Times Square has over 30,000 lights that add up to a total power of this many watts. How much does it cost? So for New Year's Eve, they keep it running for the 24 hours. How much does it cost to have that ball on for 24 hours? All right, so same steps as before. I need my power in kilowatts and my time in hours. So my power, 1290240 watts. I need to change that to kilowatts. There are 1,000 watts in a kilowatt. On your equation sheet, when I divide this by 1,000, it just moves the decimal place. So I end up with 1290.24 kilowatts. My time, it's already in hours, 24 hours. Okay, I am set and ready to go to solve for work in order to find out the money. So I take my power, 1290.24 kilowatts. I set it equal to the work done over the time in hours, which is 24. Once again, I multiply off the bottom. That will give me my work done in a kilowatt hour. Typing it in, I get 30,966. You may round slightly differently than I do. That is the work done, that's 30,000, in a kilowatt hour. My last step, now that I know how many kilowatt hours there are, I need to multiply it by the price. Every kilowatt hour costs you 0.101. So if I multiply that by 0.101, I find it costs over $3,000 just to light that up for one day. I got like 3,128 for my dollars. Okay, and they don't keep it on. Now that it's a tourist attraction, they keep it on every day of the year. It costs over $1 million to keep that thing running just in electricity. All right, so the difference between a toaster at about 2 cents and the ball in New York's Times Square, it's quite a bit difference. Okay, moving from there. So just to quickly recap, when we use our old equations, everything for power comes out in watts. But when I want to calculate the cost of electricity, I then have to change up my things slightly. The power has to be in kilowatts, the time has to be in hours. I solve for the work done in a kilowatt hour, and then I multiply it by 0.101 to change it into money. All right, let's do one on our assignment together, just so that you kind of get a head start on it. Okay, so cost of electricity problems. Number 1, if I ran the projector, this right here, the entire school day, which was about 400 minutes, how much money would it cost? All right, so I'm going to start here. I need to find the power. it tells me that it's 300 watts. I need to, first thing, convert that into kilowatts. There are 1,000 watts in a kilowatt. That means 0.3 kilowatts is what I have to start. Some of you will start to recognize that you're always dividing that by 1,000 to change it to kilowatts. May not need to do the whole step, but some of you will want to. Okay, my time, 400 minutes. I can't leave it in minutes. I have to be in hours. There are 60 minutes in an hour. So if I take 400 divided by 60, I end up with 6.67. I am now ready to use my power equation in order to solve for the work in a kilowatt hour. So I am using power equals work over time. I know my power is 0.3 kilowatts. I'm going to solve for my work done in 6.67 hours. I just need to multiply that over. It gives me a little over 2. I'm just going to round it. I got like 2.001. So I'm going to say the work is 2 kilowatt hours. And then my last step, I need to multiply by the cost of a kilowatt hour. So I'm going to multiply it. Sorry guys, I'm messing up here. I'm going to multiply that by 0.101. And I find that that changes it to be about 20 cents. So I get 0.20, which if you were thinking of that in terms of cents, that would be 20 cents. So that's just one room. Every room in the building, it would start to add up as for parts of our electricity. All right, your goal then is to follow kind of those same steps. I did use some conversions on here as well, so you'll run into those, and I threw in a few of the old equations as well as you start to work your way through different costs of electricity. All right, text or send me messages if you have any questions. I hope it goes well for you. Thank you.